Can you see my screen?
Yeah, looks great.
All right, great. I'm Greg Williams. I'm a marine ecologist with the Northwest Fisheries Science Center. I'm on the ecosystem science team here, and I also help lead this, I help coordinate the ecosystem status report for the California current. And I'll be presenting today with some colleagues on my team, Lynn deWitt, Nick Tolimieri. They're going to be covering a lot of some of the technical aspects of this data strategies, and I'll provide a little bit of the lead in up front. But oopsie, hang on. Really, the focus of our talk, our goal is to provide some perspectives on how we adopted this Openscapes community of practice and focusing on open data science and repeatable reporting. To step back, our project itself is really all about this California current ecosystem status report. It's a fairly large task. We synthesize the stats and trends of the California current ecosystem on an annual basis for the Pacific Fisheries Management Council in pursuit of this goal of ecosystem-based fisheries management. So we collaborate with a lot of scientists from a lot of different organizations. It's a fairly complex synthesis of a lot of data streams. We're working with marine ecologists as well as social scientists, economists, oceanographers, and we have a pretty short timeline that we turn this thing around in. So besides the three of us, we have a number of other collaborators and editors. And in short, it's really that we have a bunch of people with broad and diverse skill sets that contribute in various ways with various levels of familiarity with R and with coding. So sort of sort of an advanced lesson, or I guess something that we've learned since we've adopted Openscapes is that it's been much easier, I think, with team transitions and succession as we've had some new editors move in, because we have this open pathway that everybody understands what their roles are now. Some other early realizations, just, this report has been going on since, this annual report has been produced every year since 2012, and it's changed a little bit every year. But we just adopted Openscapes, started in 2022, when I was in a class with a few other members on our team, and we realized we need to bring some of this community of practice into what we're doing. A couple of early realizations. First, that we weren't alone. There are other teams working on similar efforts that we can learn from. Second, this concept of psychological safety we were just talking about, especially for me, it resonated because this idea of welcoming novel perspectives, everyone has something to contribute. It removed the fear of speaking up. And oftentimes, I don't have a large background with GitHub and R. So getting those introductions made it a little bit easier. I'd say a lot easier. And then third, this concept, I don't know if you probably built your pathways already, but I felt like this pathway step was super essential for us. It was a really valuable first step. Essentially, it's building a conceptual model that moved our entire team into a singular understanding of how things work. I mean, it sounds simple, but it really resonated with me and with our team, because then again, like I was talking about that transition and succession, people understood sort of how things work. So the rest of our talk here, I'm going to have is going to be organized in a sense following this pathway. So on the far left here, we have the data streams. I'm going to hand it over to Lynn in a second. She's going to talk about this part of it. And then Nick is going to pick up and talk a little bit about some of the R coding and how we moved into using Quarto to build this final document. So with that, I'll pass it to Lynn, and I'll keep moving the slides ahead.
Hi, everyone. As Greg mentioned, the ESR is an annual report. So our data providers generally don't have their data ready until the end of the year. This means that we only have 6 to 8 weeks from calling for the data in December to when the report is presented to the Fisheries Management Council in early March, as shown in the timeline in the center of the slide. On the top of the slide is our previous workflow, and our newly implemented open science workflows on the bottom. Over the course of the last few years, we've been working on transforming every aspect of the workflow. We've eliminated emailing of data, inconsistent file formats, and time-consuming text writing in favor of open science tools. And we've implemented a project management system on GitHub to track the progress of our workflow throughout the reporting season, and also to keep notes on improvements for the future. But the best thing about our new workflow is that it leaves a lot more time for actually doing science. Next slide. The Openscapes team has put together some really great references on data management and scientific computing. And the next few slides are some examples. I'm not really going to go through them in detail, but we do encourage you to read through the references and apply them as appropriate to your own workflow. So deciding on a file format was an important first step in our data-driven project. There are a lot of possibilities. Next slide. For us, we have a lot of indicators, but each file is actually very small. And we wanted the data to be easy to manipulate for all our data providers. So we just went with simple spreadsheets exported to text CSV files. Our spreadsheet format follows almost all of the basic principles listed here, but I'm going to focus on two of them, tidy data and metadata, numbers 5 and 6. Next slide. So what is tidy data? Data is tidy if you organize your file so that each variable forms a column, each observation forms a row, and each cell is a single measurement. But how does that look like with real data as opposed to cat names? Next slide. It turns out that the original CCIEA team developed a structure for CCIEA data that was actually tidy. Some called it long format back then. The CCIEA format consists of data with the columns listed on the bottom left. This is an example of species abundance time series where you have the time series for each species stacked on top of each other. What's important for us here is not what we've named the column headers, but rather that they are consistent down to capitalization across all the data sets. Next slide. The great thing about this format is that all of our 650 plus indicator time series can be represented this way, whether it's species abundance, stream flow, or anthropogenic drivers, or even basin scale indicators like PVO. Next slide. So no matter the indicator, having tidy data with consistent column names means that all our data can be handled by the same R code and scripts. And this facilitates automation and ingestion into our data server, ERDAP. And hence the phrase, tidy data sets are all alike. Next slide. So yay, we're done, right? Next slide. Actually, no. As more data providers came on board, emailing of data and metadata became a nightmare. People were sending their data any which way, causing code to crash. And because we didn't want to bother the data providers, we were just formatting the data ourselves. Data management became a huge messy chore. So we set out to design a workflow that was more efficient and reduced our workload, but without placing any more burden on our busy data providers and scientists. Next slide. We designed an uploader where data providers can view their current metadata, download their previous tidy files, and so we can tell them this is what your data is supposed to look like, and upload new data or metadata. It's actually quite simple. The download, upload buttons on the page just lead to Google Drive folders organized by data provider and ecosystem status report year. But the data and metadata end up nicely organized in one place rather than buried in email threads. You might ask, why Google Drive? It was just an accessible and simple solution for us, and it takes care of login and upload security issues. Next slide. Along with the uploader, there's a status page that tells us and the data provider who has uploaded their data and whether it's compliant. After it's uploaded in the correct format, the data is ready for product generation and serving via ERDAP. But what about the metadata? Next slide. Metadata, or sometimes referred to as a data dictionary, is just as important as data to help others and even the future you understand your data. Our metadata is a very large, tidy spreadsheet. It used to be a database, but the database just became too difficult to access across our data products. The one thing, though, that simplified getting metadata to all parts of our workflow was that we started treating the metadata as just another data set in itself. We serve it in our data service, or DAP, alongside all the other indicator data. So it can be accessed via scripts, in R code, from web pages, and importantly, by the data providers themselves and the public. Next slide. So to summarize, our data flow looks like this. The metadata and data are uploaded by data providers to Google Drive folders as tidy CSV files, and then to ERDAP. From there, they are available to our dashboards, indicator tables, and the ecosystem status report generation, which Nick is now going to talk about.
Hey, okay, great. So I'm going to talk about sort of the actual report production. I'm going to start out by pointing out that we do this by working in GitHub within our organization, and the organization is a convenient thing, but the main thing about it is it's basically just one place to put a multiple set of repos that you sort of helps you organize yourself. And then we have different repos for the actual report writing, and then for data handling and plot generation. So, and I'll go through sort of what happens. And then we also have different repos for each annual report, which means we are then archiving both our data and our reports from one year to the next. Next slide, please. So this is our overall workflow. After the people load their data up to Google Drive, I have an R Markdown file in one of the repos that goes about downloading the data from the Google Drive automatically, so I don't have to keep moving things back and forth. I just press go, it downloads everything. And I do some things in terms of data handling, like put on a tag that says what fiscal year the file is, and deletes the previous file and stuff like that. So there's some sort of data handling stuff I've built in. In that repo, I then plot all the figures. So we plot a lot of the figures are time series that have a uniform style. So I plot all those. Those are saved into that repo, but then also transferred into another repository, which is where the actual writing takes place. And we sort of engage with that in different ways. Some of our main authors work directly in the repo in Quarto, and some other authors will, I'll send them a little Quarto document to work on, and they'll turn it back to me. It just depends a bit on how comfortable people are with different sections of it. We then render it into a Word document and stick it up on Google Drive. Part of the reason we do that is we are working with word limits. So once it's in the Google Drive, we're not doing major editing so much as we are trying to, get it down 500 words by editing certain sections and just, but it also is a place to sort of see the final document altogether. And then we turn it into a PDF later. Next slide. So I said I have one spot where I do most of the figure making and the data handling. And this is convenient for a number of reasons. One is I can run this separately behind the scenes where the authors can be working on the main report, and I can be doing some figure editing if they want something different. One of our previous writers was very particular about figures and had a lot of comments, and so I'd constantly in there adjusting the x-axis to look slightly different. But it lets us separate those two parts of the work, and so makes it a bit easier. Doing it within R instead of something like Excel also lets me do things like I have little functions that do the plotting, and those functions then have built-in stuff that does stuff like write alt text for me and spit out information that helps me automatically update figure legends, so that it says data through 1995 or data through 2024 or whatever, that updates each year that we do it without me having to go back and edit every single figure legend. Next, please. Slide, please. So doing it in Markdown or just in R in general has various convenient things. In Markdown in particular, it'll spit all the figures out into one particular file, so then you can use them for something separate. You can also easily change the format of those figures by just changing one command. So if maybe you put them all as PNGs, but you want them as JPEGs, well, you can change that very easily for every single figure that you produce. And we're producing like 100 figures and then using a subset in the report, depending on the year. Next slide, please. And there's just a bunch of other stuff that's convenient to do there. So you can set up a lot of information that flows throughout the rest of the report, like the report year and sort of time series that the length of time series that you're analyzing for different things. You can scrape data right from websites. And again, I can download from Google. Next slide. And then I tend that because we produce a lot of the same figures for the time series, I can write little functions that then just spit out uniform figures over and over again with actually fairly limited additional commands. And then by doing that, you can also build in these other little things like your alt text and stuff like that you can then use separately. Next slide. For the report writing, the actual writing of the report, we use Quarto. Next slide. And Quarto is great for report writing. And so like if you do any kind of like trawl reports at the end of the year or something like that, where it's like really kind of an iterative process, it's great because what it's allowing you to do is really combine word processing and code so that you could say that like in 2024 we caught 4,000 pounds of sablefish, which was 20% more than last year. And those 4,000 pounds and that 20% can come from your data file and from some math that you do in Quarto. And then you don't have to write that every year and look it up, and it's consistent. And you can just kind of like spit out most of your report without actually having to do anything. So easily updated from one year to the next. And then this is in the separate repo, and we archive the data, the figures, and some things like captions that automatically update each year. Next slide. Our authors then work in separate chapters, and this is a really convenient way for having lots of people on the same document, while not being on the same document. So we have all these individual chapters. Next slide. And when you're looking at Quarto, you can integrate with it in different ways. It's sort of at the most basic way, it has two different ways to look at your Quarto document, either as visual or as source. So I tend to be integrating it with it in the source section, where it shows me a lot of code. And you have to do things like put a pound sign in front of your titles to make them section headers. You can also, there's just a button you click and it will sort of semi-render it into the visual side on the left, where you can just use like control bolds to bold things and that type of stuff. You don't really have to doesn't show you as much code. And if you're just there to edit like you would in a Microsoft Word document, it's pretty easy to do that and not have to worry about the code sections too much. Next slide. It has a lot of features that are super convenient, like being able to cross-reference figures. So like when you make a figure, in this case, I'm just loading a figure I already made. It has a name, and then I can cross-reference that name very easily. And it'll be might be figure 5, but if I move it around, it could become figure 7 automatically. And you can cross-reference tables, sections, appendices, all those sorts of things. It also then gives me this opportunity to sort of automatically update my figure legends and stuff like that. I also tend to do stuff like put tags on my figures so that if the data haven't been updated yet, it'll plot this old data thing on it, because it reads a file that says fiscal year 2024 and we're in 2025, so it knows it's old. And that is, as the authors are going through, they might be working on a section like, oh yeah, northern copepods, we don't have new data yet, I can just leave that for now. Next slide. And then you can control the appearance of your output, and I think we're pretty much near the end here, through your YAMLs, which I never really understand what's going on, and mostly kind of flail my way through, hoping that they work. But you just basically tell it which files you want as appendices or main chapters, and then you can do things like set the output. If you're doing a Word document as your output, you can have a reference document that gives it the style, so all the fonts and things like that will be the way you set them. You can have citation styles, like in this case, Ecologia, and you can automatically do bibliographies and stuff like that. Next slide. And then when we're done with most of the editing in Quarto, sort of the major writing, we render it to a Word doc and do the final editing in Google Drive. And like I said, that's got a lot to do with history, sort of multiple people wanting to be involved in trying to shorten the document to the right length and stuff like that. And then we turn it into a PDF. But you could go straight from Quarto to a final PDF file to submit somewhere, or to HTML. And so if you have a, a standard report that you're happy to spit out, you can do it pretty easily. And then if you're using, some sort of templates, you can produce the same style report over and over again. For those who like LaTeX, if you're spitting out PDFs, you can use LaTeX coding to do a lot of the formatting, but you don't have to. And I think that's it for me. Or final slide, maybe. Oh no, yep. That's back to Greg.
Yep. Thanks, Nick. Thanks, Lynn. So I'm just going to wrap it up a little bit, and I wanted to take just a moment. Again, we have our core team that's working on this, but we have a lot of collaborators that we work with on a daily basis. And I wanted to say something about the fact that as we've made these transitions and improvements, oftentimes, there are a lot of people we're dealing with, and it just takes, I just want to emphasize that meeting with those collaborators one-on-one, actually, it might take a little time up front, but once they understand the workflow, it's much easier down the road. So it's not an untenable task to do that. So I'm just going to do a quick summary of some of these open science workflow benefits that have accrued for us. Again, the timeliness is, we're on such a short time span. Doing this has really sped up our process. Much more consistent in terms of data and project management. Efficiencies have improved using these collaborative tools. We're meeting these FAIR data standards for findable, accessible, interoperable, and reusable workflow, and the transferability elements with regard to institutional memory and succession planning. I think it's easing that as well. And then I just want to highlight some of these ongoing efforts that we've adopted from the Openscapes culture. These seaside chats have been invaluable. We've been doing this on a regular basis, especially during the report writing season. And we've been using GitHub projects to benefit and learning additional tools within that project tool. We're also adapting to these novel science platforms, using Quarto, other things. We're improving the interoperability of code, and we're scaling some of these data. We're better able to scale them to some of our to regions or stakeholders, like sanctuary condition reports. We're scaling some of these products down there, and then finally, we're continuing to move beyond static paper documents to these dynamic web-based reports and technical documentation. We're pretty far along in that by repeating some of the things that the Northeast Center has done. So anyway, hopefully we have some time for questions. I just wanted to highlight some of the really nice eye candy, some of the products that we've been able to produce on our website and in collaboration with the production of this report. So thanks for your time. And I will stop sharing here.